Okay, so this is the last problem of optimization and actually the last problem of the unit. Um, it's been fun. I hope you've enjoyed these videos. And of course, I saved the best for last. The very best problem for last. Okay. Alrighty. So let's start by finding, let's see what they want. We're given 600 feet of fencing, and we're going to enclose a corral in the shape of a rectangle with a semicircle at the top. And they want us to find the dimensions of the corral to have the maximum area. So first thing we have to do is write a formula for the area. Well, to find the area, we would find the area of the rectangle, which would be, and then the area of the semicircle. So remember, the area of a circle is pi r squared. And in this case, r is going to be 1/2 x. So this will be 1/2 times, it's 1/2 because it's a semicircle, pi r squared. So pi 1/2 x squared. So my area is going to be xy plus 1/8 pi x squared. Okay? So that is the area for the corral. Now, that's my primary equation. My secondary equation is given by the fact that the perimeter of this corral has to be 600. So the perimeter is going to be, for the rectangular part, it's going to be x plus 2y. For the circular part, it's going to be the circumference of a semicircle. So the formula for the circumference of a semicircle is 1/2 pi d. In this case, d is simply x. Okay? And this is equal to 600. So now we have to eliminate one of the variables. And I think I chose to eliminate y. So I'm going to solve for y in this equation. And I get y is equal to 600 minus x minus 1/2 pi x all over 2. I told you I saved the best for last. So now the area formula is going to be x times y. So x times 600 minus x minus 1/2 pi x. Let's simplify this a little bit because it's getting a little ugly. Let's simplify this. Let's go ahead and divide this by 2. So this gives me 300 minus x over 2 minus pi x over 4 plus, and I'm adding this part of the equation, pi x squared over 8. I'm going to distribute this x to get 300 x minus x squared over 2 minus pi x squared over 4 plus pi x squared over 8. Okay? Now, all I have to do now is just take the derivative of this with respect to 8. X. So this is dA dx is equal to 300 minus, taking the derivative of that, I get x minus, taking the derivative of this, I get pi x over 2 plus pi x over 4. So, and I have to set that equal to 0. So I get 300, if I move 300 to the other side, is equal to I'm trying to skip too many steps at one time, so let me just go back and do it all at one time. So I get 300 minus x. And if I can combine these two together, and I get pi over 4, negative pi over 4, pi x over 4, and all of that's equal to 0. So moving everything to the other side, I get 300 is equal to x plus pi x over 4. Factoring out an x, I get 1 plus pi over 4. So I get x is equal to 300, 1 plus pi over 4. Now, of course, I'm not going to check to see if this is a max or a min. I'm just going to trust that it's a max because it's ugly. And then, of course, to find y, I would have to go back and replace this beautiful thing into the formula for y to find the dimensions. And that's how you do that problem. So didn't I say the best for last? Okay, that's it for this unit. It's been a pleasure working with you, and have a great evening.